This time it is quotient rule, how to differentiate one function divided by another function. So if you have y equals u over v, then dy dx is this v times derivative of u minus u times derivative of v all over v squared. And the order is important because we've got a minus in between. So using that, let's try this down here.
Okay, so will it be like, so x is equals to, so x times,
And I'll before, so we don't have to do it all in one go. Let's say u equals x, v equals 2x plus 5.
yep.
And then differentiate both of them.
So will it then become, so will it be 2x plus 5 times by 1?
Again, you're trying to do a lot. Differentiate both of them.
So is the differentiation of u 1 and differentiation of v 2?
Yeah, and then you can sub them in. Be easier now that you have all 4 written down.
Yeah. And so will that just be 2 times 2x plus 5?
No.
Is it not? Oh.
What is du dx?
2.
That's dv dx.
Oh, 1.
Yeah.
So it'll be just, will it be 2x plus 5 times 1?
Yeah.
So that'll just be 2x plus 5?
Yeah.
Minus x times, that's minus 2x. All over 2x plus 5 squared.
2x plus 5 squared. Believe that's it. And the top kind of, they simplified the top. Was the top simplified to?
Just 5 over 2x plus 5 squared.
Yeah, that's fair enough. I didn't notice that. Okay, and so yes, so it's similar to product rule, the way it's those two like that. But the order is important, and you have to have a minus in between, and it's divided by v squared. Quotient rule, I think, is given to you. Let's see. So let's try the very last one, e.
Okay. So, u is equals to 6x.
Yeah, let's actually try. Yeah, okay, I'll do e then. U is 6x.
And v is 5x plus 3 to the power of a half. And then do I then need to do 5x plus 3 to the power of a half?
Differentiate first.
And so will that be, so if u is equals to 6x, it will just be differentiation is u is 6. And the differentiation of v, would that be like half, then
a third?
Is it a third?
Yeah.
Okay.
Oh, you're right, it is a half. I didn't see it. Yeah, a half, sorry.
And then a half, 5x plus 3 to the power of minus a half. And then I had to times it by 5.
Well done.
So would that just be 5 over 2 to the power of 5x plus 3 to the minus half?
Yep.
And so do I now do, so that'll be equals to 5x plus 3 to the power of a half times by 6 minus 6x times 5 over 2 times 5x plus 3 to the power of minus a half. All over 5x plus 3 to the 2 1/2 squared.
Yes. Any idea what the bottom simplifies to?
5x plus 3 to the power of 3 over 2.
I think so. Oh, no. Not 3 over 2.
It's just 5 over 5x plus 3.
Yeah, I believe so.
Yeah.
Just want to take a look. It was... hang on, are we doing this? Yep. So they did some malarkey and simplified it a lot, but I'm not going to mess around with that. Not unless we have to.
Yeah.
Okay, we've got this stuff. Sure. What is the derivative of e to the 4x?
Was that just like 4e to the 4x?
Yeah. What's the derivative of ln x?
Was that like e to the ln x?
It is 1 over x.
1 over x, right? Okay.
Let me just see. Okay, I think that other than that, that's gonna be fine. Okay. Okay. Alright. I'm gonna keep going. Let me think. I think I'll be fine. We'll do 1. What's question 4?
So the point 12 to end the curve of Quotient. So I think do I differentiate it first?
Yeah.
And so that will become x plus 3 is equals to u, 2x plus 1 to a half is equals to v. Differentiate both of those, which will then become differentiation of u is 1, differentiation of v is a half to 2x plus 1 to the power of minus a half. 2. So I think it just becomes in the end just 2x plus 1 to the power of minus a half.
Yep.
And so after I do 2x plus 1 to the power of a half times... Oh no, just so it's just 2x plus 1 to the power of a half.
Okay.
Minus x plus 3 times 2x plus 1 to the power of minus a half.
Yep.
All over 2x plus 1 to the power of a half squared. And I think that's our answer.
And so this one wanted something, the value. So
I want you to sub in 12 into the x value.
Yeah, that's it. And let me just say here, the bottom is v squared. That squared I think is just 2x plus 1, which might make it a bit easier for the substitution. But you would then, how would you show you're working out for subbing in 12?
Would I just sub in 12 for each x value?
Yeah, so you literally have to do like 2 times 12 plus 1 to the power of a half minus ... you know, all of that. And it should work out. And to check your answer, we could do shift thing for d by dx. Fraction would be x plus 3 on the top bottom would be 2x plus 1. I have a suspicion about this one. To the power of 1 over 2. And x equals 12. X equals 12. It's 0.08. That's not bad. Let me just press answer. 0.08. That's what? 8 over 100. 4 over 52. 2 over 25. So I think at some point in there it was like 4 over 625 or something like that. And then you square root it, because the power of a half is square root. So you won't always get an exact answer. But here, even with the calculator, we got exact answer. Okay, you're good. Let's try this thing.
Okay, so let's see the equation. Is it the same kind of concept?
Yeah. And
So,
the reason why you have to use the quotient rule is because it's, x over x. It's a function divided by a function.
So I can use the quotient rule for basically any fraction that comes up as a function.
Yeah. So, but it would that's quotient rule. No one likes using the quotient rule. It's a big difficult thing. If it was something like 1 over e to the 2x, then there'd be some easy way, e to the minus 2x or something. But if it's an x over an x, function over function, then we have to use quotient rule.
Yeah. Okay. So am I doing u is equals to sine x?
Yep.
V is equals to e to the power of 2x.
Mm-hmm.
Differentiation of u is cos x.
Mm-hmm.
Differentiation of v is 2e to the 2x.
Mm-hmm.
Then I do e to the 2x times cos x.
Mm-hmm.
Minus sine x times 2e to the 2x.
Yeah.
All over e to the 2x squared.
Okay. 2x squared. Find the coordinates of P. How do we do this thing?
So I just found out the gradient, didn't I?
Gradient function, yeah. dy dx. What do you know about stationary point?
It's equal to 0.
What's equal to 0?
The differentiation.
Yeah. At a stationary point, dy dx equals 0. So how do we solve this crazy fraction?
My calculator give me the answers.
It might be a 0 marks question. If you have a fraction and it's equal to 0, there's something you know right away about it.
Is it that does that mean that the denominator can get cancelled out?
Yeah, you can't divide by 0. So anything divided by, say 0 divided by anything gives you 0. So right away we know that the top part has to be equal to 0.
Yeah.
What's next?
Do I need to do the 2x cos x equals to 2e to the 2x sine x or?
I think that you'd think so. You could. I'll give you a quicker way. Factorize.
So that am I factorizing e to the 2x out?
Yep. Factorize anything.
And so will that then become cos x minus 2 sine x?
Yeah.
And then I can just do cos x minus 2 sine x equals to 0.
Uh-huh.
Do I now need to do cos x equals to 2 sine x?
Sure.
And do I then just do divide both sides by cos x?
Yep.
And so that'll become just 1 equals to 2 tan x.
Mm-hmm.
And so a half equals to 2 tan x. No, half equals to tan x, sorry.
Mm-hmm.
And so do I now do octan over half?
Yep.
And they've given us some sort of range, I think, for the x value, yeah. So does that mean I need to do it in radians?
Yeah, because it's pi.
I put tan. Oh, I need to do octan and a half.
Mm-hmm.
I didn't get a good number.
3 sig fig.
So I got 0.46. 4.
4. Do we have an additional answer in the range?
Maybe.
How do you get second answer for tan?
Is that by doing pi plus 0.464?
Yep. Will that be bigger than pi?
Yeah, it will be then.
Yeah, so it will be outside the range. And so that's our answer. You glossed over something though. You had something times something equals 0.
Yeah.
Was there another possible answer in there?
Um,
I'm not sure if you recognized it, but like basically e to the 2x could be equal to 0.
Oh, right.
But there's no solutions for that. It gets close to 0, but never never reaches 0. But yeah, something times something gives you 0. Okay, let's see. Big picture. Stationary point. Dy dx equals 0. It's a function divided by a function. And so quotient rule. Dy dx equals 0. It's a fraction. So the numerator equals 0 because you can't divide by 0. Factorize and solve. This one, no solutions. This one, there are solutions. One solution in the range. And 0.464. They checked their answer. Oh no, sorry. Coordinate.
Okay. So I'm doing sine 0.464 over e to the 2 times 0.464.
Yeah, if you're smart, you'll use the answer button. Do you have save as answer?
I'll just do it now.
Alright. Or you would do it with 5 sig figs because the final answer is around 3.
Okay, and I got my next coordinate was 0.177.
0.177. 0.177. Grant. Okay. Any questions here? Let's see. Find the stationary points of this curve. I think you'll be alright. What malarkey am I up to there? Find dy dx. I think you'll be fine for that. Ba-da-bum. We better do one of these. Holy God. Right, how about this?
So am I doing again like e third x equals to u and a third e v equals to a third e?
No. It's in the
sorry, yeah, v equals to x.
Yep.
And differentiation of u is a third e to the third x.
Mm-hmm.
Differentiation of v is 1.
Mm-hmm.
And so I then do just a third e to the third x minus e to the third x.
Hang on. I think it's the other way around with this formula. Yes, v is first. So other way around. Because for product rule, it doesn't matter because they have plus in between. So it's v.
Oh, right. So yeah, so it'll be x times a third e to the third x.
Mm-hmm.
And then I do minus e to the third x.
Mm-hmm.
Yeah. Or yeah, and so I do all over x squared.
X squared. Okay, tangent to the curve.
Do I now need to do sub in? Oh no! So I've already got. So that's the gradient. I know what x and y is. Do I need to? If I sub in the number 3 for all x values, that'll give me the gradient.
Yep. And they want an exact thing.
Yeah.
I'm writing this to show my working out.
So right now I've got 3e to the third minus 3e to the third.
Uh-oh. Okay.
All over 9.
So what does that make?
0.
That seems wrong. Let me check this quickly. 1/3 e to the 1/3 x. We missed something out. This one here, chain rule as well. No, we didn't. We multiplied it by a third. 1/3 e to the third x. Yep. And then the other one is x1. So vu dash 1/3 x e to the 1/3. Oh, sorry. This is up in the thing. Is up in the power. Yeah. Sorry, I wrote it like there. So it should actually be 3. So just, yeah, it's like a third times 3 and then a third times 3 in the power. So it's just 1e.
Yeah.
Sorry, I wrote it as a big one. So that's just 1e. Okay. That's our gradient. What is next?
So now, do I just so do I just sub in? Oh, so now do I just do a 30 equals to e minus 3 to the third over 9 times 3 plus c?
Mm-hmm.
And then do I just do like c is equals to a 30 minus 3e minus 9e over a third over 9?
Yeah.
And divide that on
Equation of the line. Is that the answer? Let's see. And so what's the equation of the line?
Y equals to e minus 3 to the third over 9 x plus a third e minus 3 to the third over 9.
Yeah, and they didn't ask us to do anything. We could multiply everything by 9, and maybe there's stuff that can be. There's probably lots of stuff. These two might actually count. No. So was it 0? 1/3 e. Huh. It was 0. The gradient was 0.
Oh, right.
Alright. That would have made it much, much easier.
Mm-hmm.
Alright. What was I doing? I thought I must have been wrong. That would have made it much easier. Okay, so it looks like these aren't too bad. They're not. If there's more stuff going on, the differentiation becomes simpler. Is this worth doing, or you think you'd be okay?
I think I'll be okay.
Right. Let's see this one. How do you find dy dx for this one if it's x equals in terms of y?
Do I just do dx over dy?
And then?
And then just do the same thing with v and u?
So once you've done all that and you have dx over dy, how would you get dy dx?
Oh, do I need to flip it or something, or?
Yep, it's that simple. So you'd have to do dx dy by doing like u equals cos 2y, v equals e to the y. Just fully do it, and then so that's dy. That would be dx dy, and then you'd flip it and get dy dx, and that would work out. This one. What is part A?
So the curve cuts the x-axis. So does that mean that y equals to 0?
Yep.
So will it just be e to the 0 over 3 plus 0?
Yep. What is that?
That'll be a third.
And there's a third. And is part B worth doing? It is finding the equation of the normal to this one.
Probably not.
I just think it's alright. It's one of those dx dy and then you flip it. It's just long. Equation of normal. Hey, diagram. I like these. This is exam question, but let's see. Show that at the stationary points A, B, C, and D, either cos x equals 0 or tan x equals that. So let's basically just find the stationary points. Is that worth doing, or you think you're alright with it?
Maybe try this one, I think.
Alright, I think you'd be alright.
Okay.
Let's say you can't do part A. No, I won't make it weird. Let me see. How do you find stationary points?
Differentiation then equals to 0.
Yeah. I think you'll be fine, personally.
Yeah, okay.
Unless you really want to do it, we can.
Yeah.
So differentiate this one. This looks easy enough. Hang on. Yeah, unless there's some trick in there. Just a little bit of that. These are just long and brutal. This one, sure. So they want you to. Yeah, I mean it's just you're just using that formula over and over, and it's pretty long and brutal, you know, but they're not more challenging. Show that the f of x, so you have to add these two fractions or something, and then hence find the derivative. So you end up with, so part B is just subbing 3 into the derivative of that, which seems straightforward. It's more of the same, really. Maximum turning point at A, minimum at B. What do you know about the points A and B? How would you go about finding them?
Oh, are they like the maximum and minimum?
Mm-hmm.
So are they stationary points?
Yep.
So is the differentiation then equals to 0?
Yeah. So you just differentiate this fraction using the quotient rule, make it equal to 0 and solve it. We can do it if you want.
I think I'll be alright.
Okay, quotient rule. What do you give yourself?
Probably a tick.
So the questions are never easy. They're long, you know, brutal. Gotta do it though. Okay. The derivative of tan x. Do you know this?
I don't know this.
Here's my guess.
Oh, actually, so tan x is equals to sine x over cos x.
That's my guess. Okay.
And then I know the differentiation of sine x is cos x, and differentiation of cos x is minus sine x.
Yeah. And so quotient rule that one.
And so am I now doing
It's v dash, sorry,
yeah.
vu dash.
So am I doing cos x times, will it become cos x squared minus cos x squared minus minus sine x squared?
Mm-hmm.
Or you can just plus sine x squared, yeah.
Sine squared x. Yeah, and there's probably this thing up the top, cos squared x minus sine squared x. There's probably
plus sine squared x.
that's plus. I think there's some simplifying thing for that. So simplifies down to sec squared x, does it? Was over cos squared x. V squared, yeah, cos squared x. Cos squared x. Let me see. Cos squared x plus sine squared x. What's sine squared x plus cos squared x?
1.
What is 1 over cos squared x?
Sec squared x.
So the derivative of tan x using the quotient rule is sec squared x. Fair enough. Okay, let's try these.
So am I then doing now x sine 2x over cos 2x? I think.
Slow down, buckaroo. U equals x. V equals tan 2x. So which rule are we using for this one?
Quotient rule.
It's not x divided by x.
Chain rule.
Multiplied by each other will be product rule.
Okay. So differentiation of u is 1. Differentiation of v will be 1 over. Oh no, will it just be sec squared 2x?
Yeah, and don't forget to multiply by derivative of function inside function.
So that'd be 2 sec squared 2x.
Yeah. And do you remember product rule? Well, they don't give you quotient rule, they give you a different rule. Where's tan? Yeah, so they give you the derivative of tan. Now, you need to be able to remember these things. The derivative of one multiplied by another is that. That's product rule.
So will it just become tan 2x plot times? Well, it just become tan 2x plus x times 2 sec squared 2x, or even 2x sec squared 2x.
Yeah, and it's just a bit neater. That's it. Tan 2x plus 2x sec squared 2x. Yep. Okay, part B.
Okay, so will it become sec to the power of 4x?
It might be sec to the 4. Hang on, let's think about this. So what's the derivative of everything?
4 tan x to the power 4 tan x cubed, and then sec x.
Sec x. I think that's what it might be. 4 tan cubed x sec x. Sec squared. Yes, the derivative of tan x is sec squared x.
All right, yeah.
Okay, so gotta watch for that thing. Grand. Let's see these. Yep. X times x, and so it is product rule. This second one was chain rule, which is just, function inside function. You use it all the time. Okay, how are we doing this one?
v is equals to 1 over sine x. Do I need to do like u is equals to 1 and v is equals to sine x?
You would, and that would work. But that would really be overkill. That'd be only if you have like an x on the top. If you have just a number, like the derivative of 1 is 0, and so one of the things will be obliterated anyway. What might be easier is if you did that is sine x to the minus 1. The other way will also work. But let's try this way.
Okay. So am I then doing minus 1 and then sine x to the power of minus 2 cos x?
Yeah.
And so that would become minus cos x times sine x to the minus 2.
Yeah. Minus cos x, which is the same as over sine squared x. Okay, let's simplify this one.
And so am I changing sine squared x to 1 minus cos squared x?
I think, what if I wrote it this way? And that's over sine x sine x.
So that will become minus cotan x and plus 1 plus cosec x.
Times.
Oh, times cosec x.
Yeah, and that's what they were looking for.
Okay.
X cotan x, great. Your way would have worked, I think. It would have just been taken a long time, and you would have gotten this answer here, I think, minus cos x over sine squared x.
Yep.
And you also could have, I think there's a, no, it's fine. Okay, got it. So I spoke too soon. That's what they did. They did it this longer way, and they got the same thing. All right, fair enough. You really, if you like, it's for an x over an x, function over function. If one of them is a number, you can use chain rule.
Yeah.
Because that's what you've been doing the entire time. You only use it if you need to. Okay, they give you some of these in the formula booklet, and we just proved one of them. I'm sure we could prove the others. Okay, let's try A.
So I'm guessing now I need to do like u is equals to cosec 2x, v is equals to x squared.
Yeah, I think that's the only way to do it. Okay.
And so then do differentiation of v is 2x, and it says there, so the differentiation of cosec 2x is going to be minus 2 cosec 2x cotan 2x.
Yeah, so that's the result we just proved. Okay.
And so now I do x squared, or even just minus 2x squared, cosec 2x cot 2x, and then do minus cosec 2x times 2x.
Okay. minus 2x cosec 2x.
Yeah.
Yeah.
And then
All over v squared.
yeah, all over v squared.
What's
Also,
v?
just gonna be x to the 4.
That's x to the 4. That's it. And that's all they wanted. That's all I'm giving them. They factorized it. Fair enough.
I think they got x cubed.
They factorized it, and so
Right. Sorry. Yeah.
you would end up doing that comes to 3. Get rid of that one. Get rid of that. Because they've got, you can factorize out minus 2x cosec 2x.
Yeah.
And b.
So that will become sec cubed x. Should I just do sec x on its own without the cubed?
I would do sec x and then like that cubed.
Yeah.
It's literally the same thing.
So if I do 3 sec x squared and then times by is that, I think it's just going to be sec x tan x.
Let me think about this. I think it's just tan x.
Okay. So tan x.
Like if you use the formula from the start, it's because so we have to times by the function inside the function. What is the derivative of sec x?
Just sec x tan x.
So then it's sec x tan x like that.
Yeah.
And so simplify.
And will that then become 3 sec cubed x tan x?
I think so. Let's see. So the derivative of this thing is 3 sec squared. Sorry, yeah, like 3 sec x squared or 3 sec squared x. And then it's times the derivative of sec x, which is sec x tan x. Looks like it. 3 sec cubed x tan x. Yep, that's it. Any questions about either of those?
No. No.
Okay. Oh my days. Yeah, these ones. Hang on. Whew. Before we do that. Holy moly, there's a million of these things. Find dy dx, number of stationary points. Massive questions. That's kind of different. It's kind of different from what we were doing. Am I crazy? Let me see. Might be useful. Oh wow. Yeah, maybe those are the ones we have to do. Okay, how about this?
Okay.
But this is exactly the same as the other one. Hang on, how about this?
So that will become
No, it's too easy. It's not reflective enough, I don't think, of what you'll be doing. So this kind of, see, there's a part B for this one. It's just important. Right, let's go for this one.
So ln cot 2x. So is the differentiation? So this is the product rule, isn't it?
This is all sorts of rules. I think it's double chain rule.
Do I need to differentiate ln cot 2x to get 1 over cot 2x?
So that's 1 over cot 2x. Differentiate the derivative, times derivative of function inside function.
Oh, and so that'll be 2 times 2.
That's the function inside function inside function.
So
The function inside the function is cot 2x. What's the derivative of cot 2x? There we go. Formula booklet.
so they actually give it to us?
Yeah. So derivative of cot 2x.
So that will be cot, minus 2 cos x squared 2x.
So I'll put it there, something like that, because we already did the times 2 thing. So we'll just do it all in one go then. Sorry. So minus 2 cosec squared 2x. Okay. We have to get this.
So do I now need to just do put minus 2 cos x squared x 2x into the numerator?
You could. Let's see. What is cot 2x the same as?
1 over tan 2x.
This is tan 2x. That's the same as sine 2x over cos 2x?
Yes.
Oops. This thing is the same as sine squared 2x, I think.
Yeah.
So that's sine 2x, sine 2x. What's going to happen there?
Do I need to times by fractions together?
Yep, simplify first.
So sine 2x over cos 2x is tan 2x.
I think this goes come backwards. I think you can do that.
Oh, alright, yeah.
And
is that minus 2 over cos 2x times sine 2x?
Yeah, I'm missing something though. Ln is 1. I don't know. If you use the chain rule and then use trig identities, and then use trig identities. So there's some trig identity. Minus 2 cos x squared to 2x over cot 2x. Oh. Trig identities. Well, you're not really telling me it in there, Bookie. What are the trig identities? So that's tan 2. Trig identities. Tan 2x would be tan x plus x. Is that what they refer to? Okay, yeah, use your trig identities and you get this thing. Minus 4 cosec. I'm just not sure about the 4x part. Like, how are you going from 2x to 4x? We won't get to the bit that I wanted to get to. So B, find the equation of the normal. How would you find the equation of the normal?
Minus 1 over m of the gradient.
Yeah, how would you get gradient?
Differentiation. Yeah.
So we just did that.
And so that will be sub in pi over 8 into the x value.
Yes. And how do you do cosec in your calculator?
Minus 4 over sine 4 times pi over 8.
Yeah. Times pi over 8. That gives you the gradient. Then we get the negative reciprocal of that gradient. How do you get C?
I just do sub in my. So if y is equals to ln, do I just do ln cot 2x equals to. Sorry.
How do you do cot 2x in your calculator?
1 over tan 2x.
Yeah. Ln 1 over tan 2 times pi over 8. That gets you y. This is m. You have x. And then sub them all in to get c. That's it. Okay. So that stuff so far, what do you give yourself?
Probably a tick.
Hey, I don't even give myself a tick for that stuff. Yeah, how's that for you, Andrey?
Yeah, that's good, thank you.
Continue this next time.
Yes, please, yeah.
Any questions in general?
No, I don't think so.
All right, well done, Andrey. You did great. I look forward to talking again next time.
Thank you. See you on Friday.
All right, take care. Goodbye.